All right. Hello and welcome to our factoring part 2 video. This time we will be taking factoring a little bit farther and we will be actually solving for x. So let's just get right into it. So we're looking for factors of 6 that add to negative 5. So we're looking for negative 3 and negative 2. And then we have x minus 3 times x minus 2 equals 0. And then to actually solve for x, right, only one of these needs to be 0, right? Because if this is 15, but this is 0, you're still getting 0. So you solve for it by going x minus 2 equals 0, and then you don't even really need the parentheses, x minus 3 equals 0. And we can see pretty clearly x equals 2, x equals 3, right? Because you're just adding. All right, so bam, easy as that. X equals 2, x equals 3, perfect. Let's move on. X squared minus 3x plus 1, all right. So we're looking for two factors of 1 that add to 3. Doesn't exist, right? The only factors of 1 are 1 times 1. So is there anything else we can do with this? We can't factor it by grouping because there's not enough terms. And I mean, actually, let's try it. Let's see what happens because we can make more terms. X squared minus 2x minus x plus 1 equals 0. So let's try to solve this by factoring by grouping. So we can take an x out of this. That gives me x minus 2. And then we can take nothing out of that. Yep, so we can't factor it by grouping. All right, so there is no way to factor this problem. So what are we going to do about it? We're going to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So when can we use this? We can only use the quadratic formula on quadratic equations, right? And a quadratic equation is a polynomial with a degree of 2. For example, 5x squared plus 3x plus 3, and degree of 2. And that is a quadratic equation as it is a polynomial with 3 terms that has a degree of 2. And again, degree, that number right there. Quadratic equations can be any kind of polynomial where the highest degree is 2, and a, which is that first term, cannot be equal to 0. Obviously, right? Because if a was 0, then we wouldn't have a term. It just all go to 0, right? We wouldn't have a term with a degree of 2. All right, so let's use our quadratic formula to solve that problem that we couldn't solve earlier. So before we start anything, we're going to write it down. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our a, this is our b, this is our c. And it's important to remember that our a, b, and c terms are only the coefficients, not the variables. Okay? So let's just go for it. X equals negative b, right? But b is negative 3 in this case. So a negative times a negative is a positive. So we just get 3 plus or minus the square root of b squared. B is 3, so 9 times 4 times 1 times 1 all over 2. So x equals 3 plus or minus the square root of 9 times 4 is 36. 36. Right? 36, I want to say. Oh, wait, no, that's why that felt wrong. Ooh, that was too big. Minus 4. Okay, there we go. Then we just get the square root of 5 over 2. And then that's as simple as it gets. We have x equals 3 plus square root of 5 over 2, and x equals 3 minus square root of 5 over 2. So it's important to always write out both of these because we see right here we got the plus or minus. So that means just like this first example, x can be more than one thing. All right, so we're moving on to number 2. The quadratic equation is solved for 2x squared plus x minus 4. Let's write it down again. And you should be writing it down every time these first couple. It's just, it'll help for memorization. X equals b plus or minus b squared minus 4ac all over 2a. So let's just plug that bad boy in. X equals negative 2 plus or minus the square root of b is 1. B is not 2. B equals negative 1 plus or minus 1 minus 4 times 2 times negative 4. All right, it's all over 2 times a, which is 4. So x equals negative 1 plus or minus the square root of negative 4 times 2 is negative 8. Negative 8 times negative 4 is 32. Of 1 plus 32 over 4. So x equals negative 1 plus the square root of 33 over 4, or x equals negative 1 minus the square root of 33 over 4. That was a rough x. And then, sorry, give me just a second. All right, so the final answer for x. And for this, I guess, class specifically, I'm not gonna care too much if you simplify that. Like if you had a square root of 16, I wouldn't really mind if you square root of 16 is a bad example. Square root of what, like 8? Yeah, square root of 8. Square root of 8, right? Because square root of 8 is just the square root of 2 times 2 times 2. And the square root of 2 times 2 is 2, because that square root of 4 times 2, and then root 2. So let me make sure I did that right. Yeah. All right. I'm not going to make you do that for each of these. It's not too important. It's a good skill to practice, but it's not important for this specifically. All right, so on to the next one. We are going to write down our quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug that bad boy in. X equals negative 7 plus or minus the square root of b squared, which is 49, minus 4 times a, which is 12, times c, which is 1, minus 12, all over 2 times a, which is 6. So x equals negative 7 plus or minus the square root of 49 minus 12 is 35 over 6. Can you simplify 35? What are the factors? 35. 7 times 5, no. 35 times 1, no. Are those the I think. Yeah, no, so you can't simplify that square root. Okay, so now we know the quadratic formula, but where does the quadratic formula come from? The quadratic formula comes from completing the square, which I promise is a very, 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 very important skill that will make your life so much easier. It makes manipulating algebraic equations so simple. All right, so we're going to start with just x squared plus 6x plus 5 equals 0. I know that we could factor this. There's a ton of different ways that this problem could be solved, but it's just an easy example for completing the square. So x, so we're moving the constant to be on its own. So x squared plus 6x equals negative 5, right? And then I do want to make sure that I'm doing this part correctly. So sorry, I just like to have the solution in front of me while I'm so I make sure I'm not giving you bad information. All right. So yep, we're moving the constant to be by itself. Right? And then we're looking at our a term. And if our a term is anything but 1, we divide by our a term. We'll have an example of that later, but we just divide the entire expression by our a term. But for this one, that is not applicable. All right, and then this is where it gets a little confusing. So we're dividing the middle number by 2, and we're stopping there. So we have 6x. The x isn't important here. We're just dividing the middle number. So divide the middle number by 2. That equals 3. All right. Now we're taking the 3 and we're squaring it. So that gives us 9. And then we're adding this 9 to both sides of the equation. All right. And that... So if it's added to both sides of the equation, right, it keeps it equivalent. We're not changing anything about the equation. It's the same thing, right? So we have x squared plus 6x plus 9 equals negative 5 plus 9. So now we're taking the square root of both sides. And, sorry, we're not going to take the square root of both sides yet. We're not, so this should be up here. We're not taking the square root yet. Okay, so now we've added the 9 to both sides, and we can kind of recognize this front part as something that we should be able to factor, right? Because we're looking for 2 things that multiply to 9 and add to 6. That's pretty easy, right? 3 and 3. That's what we just did. Well, not really, but kind of. And then that makes this simplify to x plus 3 times x. Oh, no, it's just, sorry. That just simplifies to, yeah. X plus 3 squared, right? It's just 2 of them. For this one, I'll write it out. X plus 3, right? That should make sense based on everything else we've done, right? 2 things that add up to 6, 3, 2 things that add up to 9, 2 things that multiply to 9, 3, you put them in the form, in the factored form. And then we have that is equal to 4. And then we're taking the square root of both sides. And for the left side, because we have something times itself, that just means we get left with x plus 3, and then that means the square root of 4 is 2, and then x equals oh yeah, I shouldn't have. I do apologize about that. So right here, when we're taking the square root of both sides, right? Numbers that are under the square root can only be positive, right? Which is why we've just had a equal there. But once we take it out of the square root, that x can be a negative number. So now, where's my erase? So now we got to switch from equals 2 to plus or minus 2. Well, I mean, it's still equals plus or minus 2. But that square root of 4 just could have, because like negative 2 times negative 2 equals 4, and 2 times 2 equals 4. So it could be either of those, right? We have two different x values. It's nothing too different. Then we're just going to, let's just write it down as two separate. So x plus 3 equals 2, and x plus 3 equals negative 2. So then if we just subtract 3 from each side, we get x equals negative 1, and x equals negative 5. Yep, and that is our final answer. So that's how we complete the square, right? And you may be asking, that sounds really complicated. Why does it matter, right? Okay, but why do we care about completing the square? Completing the square may not seem super helpful because we know that the quadratic formula can solve any quadratic equation. But we use it because it is useful for a few different things, including graphing, which is a big one, but we're just not graphing yet, so that's not too important of a difference. Rewriting expressions, which is the other big one that's more important to us at the moment, and then working with circles and many other things, which we're not going to touch on. So let's show an example, right? This is I'm like 99% sure there's supposed to be a, hold on. Did I write that down wrong? Because I'm pretty sure there's supposed to be an x squared on that first one. 1 second. Sorry, I am finding the problem. I'm really just don't want to do any of this wrong. I just want to make sure that, yeah, okay. Yeah. That was supposed to be a squared. Right? Because if it wasn't a squared, it wouldn't be a quadratic equation because we wouldn't have a variable with degree 2 leading. So we can kind of see that this is a quadratic equation, and if we just x squared plus 6x minus 7 equals 0, and then we found two things that add to negative 7, which are negative 1 and 7, and add to 6. You know, we could do it that way. But this way keeps it in a form that's it's just a little bit quicker, to be honest. So we're going to do the same thing we just did, right? We're starting with the basic trinomial. We're moving the constant to be alone. It's already alone. We're dividing both sides by a. A is 1, so we don't have to. Then we're doing the complicated part. So 6 divided by 2 equals 3, which squared equals 9. So we're going to add that to both sides. We're going to get x squared plus 6x plus 9 equals 16. And then this is going to turn into x plus 3 squared, just like it did last time, equals 16. And then we're taking the square root of both sides. And hold on, yeah, we're taking the square root of both sides. So that gives us x plus 3 is equal to plus or minus 4. And again, it's plus or minus 4 because negative 4 times negative 4 is 16, and 4 times 4 is 16. So then x, so let's just write it a little separate. X equals, x plus 3 equals 4, and x plus 3 equals negative 4. So then x equals 1 or x equals negative 7. Right? Yeah. All right. And then, I mean, it was just a little bit simpler of a way to do it for me. It just meant we didn't have to rearrange the equation or anything else. So now we're getting to one of the super important parts. All right, sorry about that. The video just cut out for a second. But we're getting back and we are proving the quadratic formula by completing the square. So this sounds super complicated and super difficult. It's not, I promise. We're just doing exactly what we were doing before. Okay, so we have our ax squared plus bx plus c equals 0. So we're starting, moving the constant to the right side, equals negative c. Right? And then we can't, like in our previous steps, we had to divide both sides by a, unless a equals 1, and a was 1 in both of those. So we didn't have to worry about that, but we can't just assume that a equals 1 and hope it works. So here we have to divide by a. So we have x squared plus b over a times x equals negative c over a. All right, and then we're doing the kind of complicated step. We're taking our b over a, and we're going to take half of that. And then we're going to square it, which gives us b squared over 4a squared. Right? And we're adding that to both sides. So x squared plus b times x over a plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. All right, I turned the microphone on, right? Just trying to make sure. All right, yes, my microphone was on. Okay. All right, so, yeah, so we're combining these two, but negative c over a plus b squared over 4a squared are not common denominators. So we need to take our negative c over a and multiply it by the least common denominator, or in this case, just the 4a. So, or what's this? I have 4a squared, and then, oh no, not 4a squared, just times 4a. Yeah, because there's already an a over there. So that gives us negative, negative 4 times a times c over 4a squared. All right, so we have x squared plus bx over a plus b over 4a squared equals negative 4ac over 4a squared plus b squared over 4a squared. All right, and then we have, oh geez, we're running out of room. There you go, move that over there a little bit. So Now we combine those, these, x squared plus bx over a plus b over 4a squared equals b squared minus 4ac over 4a squared. All right, and now the next step would be to take the square root of both sides, but it would be very complicated to take the square root of this side the way it is now, so we are going to turn it into a perfect square. And we can do that because b over 2a times b over 2a is equal to b over 4a squared, and it adds to b over a, right? Because half of b plus half of b is just b, but we're keeping the a underneath it. All right, so you have that, and then we can rewrite it into x plus b over 2a squared equals b squared minus 4ac over 4a squared. And then you're going to take the square root both sides, and leaves us with x plus b over 2a is equal to the square root of b squared minus 4ac over 2a, and then you just move that across, so x is equal to negative b over 2a, and then just because of the square root, you keep the plus or minus the square root of b squared minus 4ac, and it's all over 2a. And now we have x equals negative b over 2a plus or minus the square root of b squared minus 4ac. Matches perfectly. So this is really useful because if you forget the quadratic formula on a test, you can just you can derive it. You have the proof. All right. So then we're going to use completing the square one more time. We're going to, I don't know why I use the, yeah. We're going to use, where'd it go? Completing the square one more time just to get some more practice with it. So we have x squared plus 2x equals negative 5 because we move that constant over, and then half of 2 is 1, 1 squared is 1, so we add 1 to both sides. X squared plus 2x plus 1 equals 4, and then we see pretty clearly right here x plus 1 squared, right, because 1 times 1 multiplies to 1, and 1 plus 1 adds to 2. So we have x plus 1 squared equals 4. Take the square root of both sides. You have x plus 1 equals plus or minus 2. And then you have x equals, if it's positive 2, 1, x equals negative 3. So that just, yeah, completing the square just is kind of a quicker way to do a lot of these. The quadratic formula works perfectly fine as well, and then factoring is always going to be a strong tool. So you're never, you know, of course you're not going to use all of these all the time. They're not always all going to be applicable, but remembering how to factor, how to use the quadratic equation, and how to complete the square will make you a much better mathematician. It'll make you significantly better at math, significantly better at manipulating algebraic expressions. It just makes everything easier, I promise. So remember. Please, I promise. Or else you're going to end up learning the same thing like 15 times because it just keeps on coming up and you're going to keep on needing it. And if you don't learn it right the first time, it's just going to make it take more time each time after that. So just learn it right now, remember it, and you will never need to worry about it again, and you'll be in a much better spot than everybody else in most of your classes. Especially if you can derive the quadratic formula. It'll make your life so much easier. Other than that, though, that is all for today. I'm sorry about the couple of cut-ups we had, but luckily they didn't really happen until the end. But yeah, I'll see you next Thursday, I guess. Yeah, because I'm doing this right after we finished factoring part 1. Yeah, so I will see you next Thursday. Have a great week.